Hola a todos, estamos aquí en un nuevo programa de La Hora Maker en Madrid, Mini Maker Fair. Tenemos la suerte de estar con Nadya Peek. Hola Nadya.
Hola. Oye, tío, no me dijiste que necesito hablar en español.
No, ahora cambiamos.
Ah, ok.
Y Manolo de Valencia, ¿qué tal Manolo?
Hola, ¿qué hay?
Como siempre avisamos, vamos a hacer una entrevista en inglés. Tenemos la suerte de estar con Nadya aquí en la feria que acaba de presentar sus proyectos. Y nada, vamos allá, vamos a hacer un cambio rápido en inglés. Hi everyone, welcome to Laura Maker. Hi Nadia.
Hi.
Now it gets more comfortable to all of us.
Now I know what the words are. What's a 3D printer in English?
That's perfect. So, first thing, most of the people here are aware of digital fabrication, but what do you feel like digital fabrication is?
Digital fabrication, just simply put, is computers controlling machines. And so whereas with a milling machine, like a router that's handheld, there's a person controlling it. And with digital fabrication, you have motors and a computer that is controlling motion. And the benefits of that are that you can have more precision because the computer is moving it instead of you doing it by hand. And most of the time there are things that you can do very precisely by hand, especially if you're an expert. But one thing that's easy with digital fabrication is that anyone then can have access to precision, and then once you can make precise things, you can use those to make more complex things. So you have access to precision and complexity by using control of a computer.
That's very very interesting because most people are maybe aware of 3D printers right now. They are quite usual, but are not aware of other digital fabrication means that can be really useful too for.
Well, yeah, I mean, you could think of it as digital fabrication isn't only 3D printing. 3D printing is extruding plastic or curing plastic selectively, but there are other processes that can be computer controlled, like cutting with a laser, or cutting with a water jet, or milling, or cutting with a knife, or selectively curing things that aren't for 3D printing. So there's a lot of different ways in which you can use a computer to control a machine and automate things.
And what would you say that are the key moments in the development of digital fabrication? Like people should be aware of, I don't know, open source design, or this moment in history. I think it's kind of key to digital fabrication development.
Well, I think that the origin story of digital fabrication is something that it's important not totally to forget. The reason that we have digital fabrication now is during the Cold War, people wanted to make more airplane propellers and kind of war machine parts, and there weren't enough skilled mechanics, not enough skilled machinists to build these things. So there weren't enough skilled people making parts to be able to build these things. And they wanted, the governments at the time wanted more access to precisely made parts. And so the original development of digital fabrication was to make things very, very precisely without needing too many experts. And now, you know, people think of digital fabrication more as a way to do mass production. Like Apple, for example, CNC mills, their enclosures for their phones and their CNC stands for computer numeric control. Apple CNC mills their enclosures for their laptops and their phones, and by milling them, they can achieve precision, but they also achieve volume. But volume was never the point of digital fabrication. The point was to achieve precision.
Yeah, and the other thing that I'm just, as we hear about this story, that most people, when they talk about 3D printing now, they're thinking about creating custom pieces or prototype single pieces maybe. And when they originally started, they were like trying to build in volume in some way. Like
That's another thing that is it's like a side effect. Once you program a digital fabrication machine once, it doesn't matter. It will make the same thing over and over again, however many times you want to run the code. But if you want to change the code, if you change the code that the computer sends to the machine, you can make something totally different. And whereas previously, if you wanted to make something in volume and you injection mold it, for example, you need to make molds for the injection molder. And making those molds can take weeks. So Apple, to go back to that example, can very quickly change their entire assembly line. If they changed the size of their laptops by 1 centimeter, they just change the code that all of the machines run, and they immediately change their factory floor. Whereas if they had to make new molds to make new laptops, it would take much longer. And so you can do things you can quickly change things because you're changing code, not changing physical things.
But you are now working into prototyping physical stuff. So that this is one of your projects about prototyping machines that maybe are trying to fill that gap. What are you working in that? That's yeah.
This is difficult as an interview question because you already know what I'm working on.
Yeah, it was a classical. Well, now that we're talking about prototyping, let's go to your prototyping machine.
Yeah, so I'm interested in understanding how to represent the diversity of people who work with tools in the tools themselves. So if you go to like a traditional woodworking class, then one of the first things that you might do is make a planer, your own planer. And making jigs or different kinds of tools to do woodworking with is a very normal part of woodworking. With digital fabrication, instead, we seem to have arrived at this idea, and maybe it's from science fiction, that there could be one universal machine that solves all problems, that we just have one machine that makes everything.
Star Trek replicator.
Yeah,
like press the
like
button.
Press the button and you get what you
magic.
want. But actually explaining what you want and that part, that's actually kind of difficult. And I don't believe that it's going to be easy to translate everyone's desires into products in a single machine. I think that people have very diverse needs. You know, if you're in a place without good access to the grid, you're going to need a machine that can run intermittently. If it turns off suddenly, you have to be able to deal with that. If you have a very small place, you need to have machines that can be reconfigured. If you want to have machines that work with local materials, you have to tune your machine for that process. And so I believe there is a diversity in applications that needs to be mirrored by the machines that we use. And I think the only way that we can make machines for everyone is if everyone makes machines for themselves. And so how do you make it possible for people who aren't necessarily experts in machine building to also build machines that are relevant to themselves? So my work is about understanding how to make infrastructure for machine building so that anyone can make machines even if they're not engineers or machine building experts.
That's quite a challenge, isn't it?
Yeah, well, you have to do something with your time.
That's it. What do you think, Manolo, in FabLab, when people approach FabLab, what is this something they miss? Like, okay, I need to create my machine, or they are more like trying to avoid any kind of getting deep into technology and more like users? How do you feel that it works at least into your FabLab in Valencia?
Voy a contestar en castellano.
Sí,
si
claro.
Bueno, yo creo que Nadya estuvo allí el otro día y pudo ver un poquito los proyectos que se generan.
Y beber horchata.
De beber horchata también. Y bueno, como pudo ver y también pues os puedo contar los proyectos y las máquinas o la tipología de máquinas y de cosas que hacemos, pues tienen diversas líneas o vías de creación o de sentidos por los que se hacen esas máquinas, ¿no? Es decir, nos encontramos pues gente que quiere proteger su prusa, su RevRap con su caja, porque le puede costar mucho filamento, ¿no? El no protegerlo, hasta encontrarte pues gente que interactúa entre lo virtual y lo físico, ¿no? Y luego también pues tienes aquellos que son high tech, ¿no? Es decir, más que están más preocupados por la tecnología, a ver si consigo resolver esto y tal. Y hay gente que está con una practicidad como muy inmediata pensando más en el negocio, ¿no? Es decir, es toda una...
Yeah. It's certain that there are all kind of... When people were coming to the fair today, they were like, oh, this looks very interesting, but some of these people approach from a business side model, like kind of an entrepreneur, and I want to just create my product. But some of the people just think it's more like this is like a learning platform or opportunity to explore how things work. So I think people are coming more and more close to digital fabrication to start the project or do them what they want to.
Yeah, I think it's definitely something. So earlier this week, I visited the Fab Lab in Valencia, where Manuel teaches, and a lot of students presented their projects. And they're using the digital fabrication equipment to do very different things. One person was using it to figure out how to demonstrate the geometry of hearts for doctors. If you have access to just digital information, it doesn't give you the same information as if you could hold the heart in your hand. So he's 3D printing hearts. Or another one who is making customized lamps. And to make customized lamps, you might use exactly the same technology as the person who's making the hearts. They're both 3D printing, but one of them is making custom software to interpret medical data, and the other one is making custom software so that users can make their own lamp designs. And so even within something as seemingly multi-purpose as 3D printing, now you see there are two totally different applications. And so I think that being able to even just streamline that workflow, even if the machine looks more or less the same, the user interface and the software that controls the machine is also part of the machine and also part of the workflow experience.
Yeah. No, I'm thinking about one of the most important parts you talk about in your presentation, about the ability to reconfigure the factory whole floor without having to retool everything and redesign all process, because in the end it's software that controlling the hardware. And I think that there is one question that when you talk about digital fabrication is always on the table, like, okay, is this going to replace traditional manufacturing or the way that we build and manufacture stuff? So I'd like to know your view or your opinion about the future of digital fabrication, like maybe in 5 years or 10 years, where are we moving towards?
Well, digital fabrication is already being used extensively in industry and manufacturing because it's cheaper than it once was. And so to go back to the example of Apple uses digital fabrication for making their parts because you can give a product that looks very luxurious. It looks very, it looks like digital fabrication was traditionally used for medical devices or for military applications. And so you can kind of take that design language and apply it to a consumer product. That's but let's not dwell on that too much. I think digital fabrication makes much more sense if you're not making a million of the same thing. Yeah. And I think more and more companies are starting to do that. Like Philips, for example, they make Philips Light. They make a lot of the lights all over, not just lights for in houses, but lights for street lighting, for supermarkets, and they have.
We have running kits. Let's wait for a second. Like they are maybe
they're the machine builders of the future.
So let's go back to Philips SKU.
And so Philips Lighting has maybe 120,000 different things that they make at any time, and they have to be able to change their factory to accommodate those kinds of changes. And maybe they're not 3D printing their lamps, but every time they do something, there are parts of the process that can be automated. Placing the LED panels within the enclosure, cutting the enclosures to the correct length. There are a lot of different processes involved. And if you were going to make the same thing over and over again, you could take a week to set up the factory and it would be fine, because you're going to then, if you're producing, for example, aspirin pills, your plan is going to be to produce aspirin pills for the next 15 years. So your factory, even if it takes you a month to set up your factory correctly and tune everything, it doesn't matter. But if you're Philips and you want to make 100 of a particular lamp, you don't have time to spend a month setting up the tool chain. And so how do you make rapid automation? How do you make manufacturing of low volume goods as fast as mass manufacturing without loss of precision or complexity? I think that's a very interesting question for industry right now, especially as industry is expected to conform to a consumer who expects things to be more personalized and locally relevant.
And what about distributed fabrication? Like there is like, oh, I don't think that most people will have a 3D printer at home. This is the thing that when people come to the fair, like, oh, I think it's very interesting, but I don't think I will have one of these at home because, well, maybe it's not the plan. We go as the same craziness as printers.
I think that it's there is a spectrum in everything. And also in who needs access to tools quickly and who's only going to need access to tools later. Like, do I think that, my grandmother needs a 3D printer right now? No, my grandmother doesn't have the patience to sit through the whole workflow of programming a 3D printer. But in design schools, engineering schools, like there you already see that architecture departments have had laser cutters for decades, because when you make a lot of stuff, then having access to the precision of digital fabrication and the speed of digital fabrication is a really valuable thing. And so I don't think, we're not going to say, tomorrow, just like everybody has a lawnmower, everyone should also have a 3D printer. No. And I also don't think like a 3D printer doesn't solve all of your problems immediately. It's often introduced as like the machine that can do all digital fabrication. And sometimes it kind of reminds me of the advertising, like old advertising for the microwave, where like you have a microonda. The microwave is it's like, your kitchen will be so futuristic and everything will change and you will never hold a pot again and blah, blah, blah. Like, how much do you actually use your microwave? Not that much.
We have here in Spain Thermomix, that is like a cooking robot, and it's like, oh, this is going to solve all of your problems. Sometimes it can also create some new problems. Indeed, my Thermomix is broken. Yeah. So I'm going to get a 3D printer. I have to calibrate that. There is time. I think.
And so a replication of the pastilla de entrada, no?
Then you have to make. Maybe I have to 3D print. No, it's a motor that is broken. I cannot 3D print. But that would be interesting. I don't know if you'd like to ask someone, because we usually talk about for 25, 30 minutes. I don't know, Manuel, you have any burning question in your mind, like, I have always wanted to know about.
La gran pregunta.
Yeah, you had la gran pregunta.
No, pero, por ejemplo, a nivel de, Nadia, a nivel de lo que es la accesibilidad, el acceso a las tecnologías, hablabas antes de la abuela, que si se puede adaptar o no a la tecnología, quizás llega su tiempo, o lo que más le importa es la aplicación. Pero nos vamos a encontrar con una generación de niños jóvenes que van a estar mucho más preparados por el acceso que tienen a las tecnologías a construir un futuro mejor.
I hope so. I mean, I hope that I have both hope and fear, as with many things. And kids these days, this makes me sound so old. They learn immediately, they learn how to use a cell phone before they even learn how to read. So they're like looking at videos and whatever. So they have a kind of affinity for these changing digital tools. Like if an app changes, they're fine with it. They have this kind of like ease of learning in a technological landscape that is good. But at the same time, the tools that we are giving them are very closed. Like if a child only has access to a cell phone, you can't run code on a cell phone, you can't change the cell phone. How do you, maybe they could become an app developer and then try to make an app and then get it accepted into the app store, but that's not direct access to the technology. And so I'm worried about the passive way that technology gets packaged. And sometimes it's passive because it's trying to create a really good user experience. Like you want to make sure that anyone can do it and it will always go the right way. But sometimes I would also want to advocate for bad user experiences so that young kids and also people like me and people like you intervene with the technology and help shape it. Because I think the only way that you can really truly have democratic technology is if it is shaped by the democracy. And so it's like I am hopeful because I see the kids now, they're like super fast and super smart. But I am also worried because the infrastructure that we're providing for them is limited and closes them off.
So that sounds like advocacy for open source, like
Yeah,
being able to
yes.
open and hack and
Tío, por supuesto.
sí. Aquí creo que todo el mundo en la hora maker tiene esa visión, ¿no? De compartir, aprender,
Sí.
conjunto. There is always this question of patents that appears about how do you protect the things you patent. We will not answer this today because I think
Yeah, it's irrelevant.
It's irrelevant.
Everything that you can make on a digital fabrication machine in a fab lab is so easy to make that the barrier to infringement is so low that patents are irrelevant.
Yeah.
That is a culture question, culture things of the pattern of the.
What is the culture of patents?
Problem, culture problem.
I think patents are for old dinosaur companies to try to crush new innovative companies because they don't know how to innovate. The big companies don't know how to innovate themselves, so they use any weapon they can to stay alive.
Uh-huh.
Hopefully, the weapon soon will be gone.
Okay, so to end up in La Hora Maker, we always end saying, who would you like me to interview next?
Mm-hmm.
And what would you like me to ask them? Maybe there is, given that we are like in a touring around, asking people, meeting new people every time, I might randomly meet someone like, oh, I have you in my list of, someone told me 2 years ago that they'd like to know what Nadya thinks about it. We have that list, but you can add people to the list and say,
Yes.
I would like to know what someone thinks about something. So maybe Manolo and then Nadya.
La pregunta.
¿A quién te gustaría que entrevistara después y qué te gustaría que le preguntara?
Que entrevistaras tú.
Sí,
En La Hora Maker.
yo voy en La Hora Maker por el mundo, así con este kit viajero.
Bueno, nadie te puede decir, a lo mejor más personas que yo, pero creo que sería interesante hacer entrevistas ahora un joven que esté con una idea, la quiera poner en marcha y ver todas sus inquietudes por dónde camina, ¿no? Sí.
Un poco ese reto de... Bueno, hemos estado ahora con Gerard Rubio, que bueno, el joven,
sí.
no sé, es como... Joven y tiene un
Una gran
rango
juventud.
ahora somos... hay gente que es viejo joven, ¿no? Entre viejo...
Cierto.
Pero sí, ¿no? Con Gerard, por ejemplo, estoy viendo con Iterate, que estaba lanzando el proyecto, cuáles eran los retos que él veía y cómo había pasado. Buscaremos a más gente que esté, como
Eso.
estamos aquí en Maker Faire, seguro, eso es fácil.
No, lo digo porque eso es muy interesante, ver digamos, todo lo que está sufriendo y alegrándose
Y
a alguien
los-
por crear algo, ¿no?
Ok, trataremos de acompañar a alguien más en proceso creativo. Nadya, what is your
Well, here's
proposal?
a person I think it would be good to interview about this, but I don't know if he actually wants to be interviewed about this because he likes to be interviewed about his art only. A famous artist called Jeff Koons.
Okay.
He works with us on making processes to make his sculpture. So I don't know if you're familiar with his sculpture, whether he makes these really big metal sculptures, like large format version of a balloon animal, like a rabbit,
Okay.
made in stainless steel, 10 feet tall.
I know.
And we work with him because his manufacturing requirements are much higher than those of Airbus or Boeing, so he uses airplane design software to make his sculpture, and he uses all of the most advanced digital fabrication techniques, and they're still not sufficient. So he has to build, as an artist, new technologies to make digital fabrication work for his sculpture, or to make it possible to make his sculpture. And he normally just talks about the objects, he loves the objects. But I would love to see an interview with him on how he's actually changing technology, and also how his R&D department is actually in ways more sophisticated than the R&D department of Airbus.
So he's pushing on the...
Yeah,
on
as
the
an
boundaries.
artist, he's pushing engineering boundaries much further than they've ever gone before.
Okay, and where is he based?
New York.
New York.
New York.
Then we have another check on our list.
Yeah.
Maybe we have to go there and say, okay, we were like a few months ago and we will try it.
Yeah.
Okay, thank you both of you. It was a pleasure to talk and learn about things are working. I think it would be great also to visit Valencia again for another chata in the future.
Yeah.
The other day.
Fartons.
Fartons.
Yeah.
I'll learn about how do you make fartons in a proper way. Okay, thank you so much.
Thank both of you.
Thank you,
Thank you.
Nadya.
Bye.
Bye.
Ciao.